So, hello, this is a tutorial on how to make segment transitions and elevators work. I will be using Crash 2 and I will be using CrashEdit. For this, I will be using airumu's version of CrashEdit because that's just what I use. And also I will be using a tool that I use, and a hex editor. This is the hex editor. I'm just gonna be using XD, but you can use whatever. And I will be using this tool that you can find here on GitHub, Recha, Crash to Export Releases. Just grab whichever works, probably just grab this one. So I will be using a fresh Crash 2 version. I'm just gonna use SnowGo because SnowGo is a nice level for demonstrating things. So this is just vanilla Crash 2 all, and I will just open the level and go from there. SnowGo is level E. Now, what I'm gonna be doing is creating a transition here between from this area 1E or 1D, which is in the main SnowGo segment, and I will be making it take you to this part. Just for no reason, I just picked this, and we will be using an elevator for that, and we will have to add some things to make it work. So first off, if you have it all set up and you have PCSX HDBG, you should be able to easily launch the level from the editor. The way you do that is you just have the CrashEdit folder in the same folder as PCSX HDBG. So the CrashEdit that I'm using, which is in this folder, is looking for this folder and then launching the emulator. Also, I will be changing the level spawn because I don't feel like playing the entire first segment every time I try to test it. And the way you do that is you open the NSD, which has most of the metadata. And an interesting quirk of Crash 2 is that the checkpoints also are in the spawn list, which is at the end of the NSD. I'm not going to be explaining all this before. I think I explained it elsewhere. It's not very important. So we see that 1B is 7B, switch 7B, C7, 5F, O2, and these 24 bytes or hex 18 bytes are the spawn. The first 4 are the zone, the next 4 bytes are the camera index. For example, if 1B had 2 camera paths, for example, this zone has 2 camera paths. One is the horizontal one and one is the vertical one. But B only has 1 path, so the 0th path is used, and it spawns the camera on the second point of that path. And following that are 4 bytes for spawn X, Y, and Z position each. So we just put it at the start of the spawn list so that when we try to boot the level, it uses that spawn, the very first spawn, which we have now replaced with this one. Now, the way transitions work is there are normally camera links between zones and cameras that are connected. For example, zone 1E is connected to the previous zone, which is 1D, and the following zone, which is 1F. in the camera tab, in the neighbors, we can see neighbors at position 0, which is this 0th position, and 24th, which is the last position. Zone index refers to the index of the neighbor. So when we're in 1E and we want the first neighbor indexing from 0, 0 is the zone itself, 1E, and neighbor 1 is 1D, which are these 4 bytes. So it's linked to zone 1E and its 0th camera, indexing from 0. Link type 1 means the link is at the start of this path, and flag 2 means it's connected to the end of 1D's camera. If it were 1, it would switch to the beginning of 1E, so the camera would jump from here to here, which we don't want. It should just smoothly jump to this end. And to make the transition to TA, to the secret part, we will also be using a property. Now, the easiest way to get the property, the camera property, into this zone is to get it from somewhere else. Now here are the properties used by this camera. Each camera has 3 items. The first item contains most of the properties, such as the positions, path links, list of things to draw, list of things to load. Then there's the second camera item, which contains angles and some other properties like background color, fog, and things like this. And the last item, I don't know what it is used for. It doesn't have any useful information, but it's there and you can't really remove it. So, and the camera property that we want is hex 1x128. And if you look here, these 2 bytes are the property code. These at the beginning are the headers, and they are followed by individual, like lots of data. But here at the beginning there are the headers, and as you can see, there's property 176 and property 1AA, and there's no property 1A8. So where we get that from is some area that already has this kind of transition. Now, for example, we can use this. This is the Snow Go bonus, and it takes you back to the main path, to zone 1E. So when we reprocess, we can see that the property 1A8 is there. So we just want to export this and save it as ZX camera 0. And we also want to export 1E's camera. First item, 1E C0 ES. Now then we'll be using, not this, then we'll be using this tool, which I already have here. And this tool then does a bunch of stuff. We use it to mod stuff. For example, we use build and rebuild to rebuild levels, and then there's a bunch of random scripts that we use. But what we want to use is prop replace. And prop replace is an easy way to copy property from one camera to another. So we will be copying from ZX camera 0 to 1E camera 0, and we will be using property 1A8, and it should be in 1E now. A nice way to visualize the properties is to use the prop thingy in my tool. Now it brings all the properties, and for the ones that I knew the name or the purpose for, it's listed. For example, camera mode, positions, you can see its header and its data, and we can see that the property 188 is there. And in here I can explain the format. The first 2 bytes seem to be constant. It's probably just word count. This 0018, which is 24 in decimal, is the index of the point from which the switch happens. So when Z6 has 25 positions, it means index from 0, its last point is point 24, which is 18 in hexadecimal. So the camera switch happens on point 18. Now these two I don't remember. This 8 seems to be constant, this 0 seems to be constant. These 2 bytes, this 1 byte, 1 byte is either 1 or 0, and I'm not entirely sure what it's based on, so I usually don't even touch it, I think. Then there's 10. 10 means it's elevator transition, and if you were to go into, for example, not that, 1O, okay, 1N actually. 1N, what happens in 1N is there's warp collision at the bottom of this pit that takes you into B1. It takes you into very far away into here. So 1N also has 108, but it doesn't have value 10. You can see it's the property, it's 04, then 1E, which is the point, then these 4 bytes, and instead of this 10, there's this 20. 20 means it's a warp by collision, and 10 means it's warp by elevator. And then the property is followed by 8 zeros. I don't think anyone really knows what they are. You just don't touch them. So now 1E, we move the property back. You can see it's here, 108, and we just sort of find it here. Now I can kind of do it easily, but you're just gonna have to look for it, or you could edit it in hex editor, but I prefer this. And since we will be placing an elevator here, we want the transition to happen on the very beginning, the 0th point. So we are going to be changing the 18 to 0. And I'm going to change this to 1, just because I feel like it. I think it's supposed to be 1, but I don't know why. I don't do this very often, because it's not really a common thing to sort of put segments together. You just do it just like a couple times for each level, and then it's done, and then you spend way more time on other stuff. So let's go into Z6 and into its links. Now the backwards link is to the previous zone, but the end link is connected to zone 2 and to camera 1 and 0. And when we go into the neighbors, okay, I just scroll down basically, we can see that the second neighbor is 1L, and 1L is back up, so this is basically where it takes. this path here is the catch elevator, which you sort of latch onto when this elevator sends you up there. So we will be adding a new neighbor in our zone, that new path link, a new neighbor in our zone, so that there's a path link to zone TA. Now the zone TA easy has this representation in the game. This is sort of name for entries, and it's encoded by 4 bytes instead of 5. So this is the easiest way to just convert it, or you could go into zone TA easy, into its header, into its neighbor list, press Z. You can see that TA easy is the first in the neighbor list, the zone itself, and you can see it's 7B-C7-576E, 7B-C7-576E. So we go back into 1E and we add a new neighbor, which we do by incrementing the neighbor count, which is this. You can see there are five zones listed here. We make it one more, and we write 7B-C7-57-6E there, and we use, so these numbers 1E, 10, 10, and 1E, all these are sort of just flags for what part of the neighbors is processed by this zone. I don't remember all the flags. The flags are, for example, entities, collision, and some more, but you can just use 1E, which is everything and everywhere, and for transitions you probably want to use 1F. 1F means everything, and it's a transition. So we have added TA easy as the neighbor, and now we want to add a new camera link. We just insert a new camera link, and it's neighbor 5. It's link type 1, which means it's at the beginning of this path, and for flag. Now the elevator will be coming somewhere here, so it will be at the start of the path, not the end. So we will be doing camera flag 1, which is the beginning. We will also need an elevator. We just add entity, we name it LFSend or something like that, and the easiest way to find out, I remember these, but the easiest way to find out the type, subtype, and the arguments for these is to look for the very same thing somewhere in the levels. So this level for sure has an elevator in this area, which is the first segment, and we can see that this has positions, which is just sort of how it moves. Oh no, I clicked the camera. It has the positions, which is how it moves, and it has type 9, subtype 6, and it has a bunch of start arguments, which I'm gonna explain later. So I will be going back to 1E. It will have type 9, position 6, and we will just place an elevator in this bit very approximately. Doesn't really matter. I said it doesn't really matter, and then I tweak the position. Okay, we saw it has 8 arguments. The first argument is 640, the next is 47. Why? I don't know. It just sort of is that. The third argument is the ID. This property, identification, is the ID of the catcher. So what happens when the elevator sends you somewhere? It sends you somewhere, and then the elf catch object sort of catches you and moves and then lets you go. So for that, we will be adding elf catch in the zone that will be teleporting to. This 932.00. If you don't know, you can just look for an object like that and copy it, 932, and it has empty arguments. We will name it lf catch. With D, I can move this view into another window, so I can position the object somewhat. I won't be given it a fine. No, I will be giving it a fancy path. Why not? I can show interpolation. So I want to move the. Actually, you want to have the first point where it goes. The first point is where it ends, and the last point is where it starts for elevator catch. The reason it is like that is because some elevators can work both as sender and catch. For example, if we go into cold hard crash, desktop thingy 13. If we go into cold hard crash, I think this is 3L. No, it is 2L. This elevator here sends you into the death route, and you can see it's elevator to hard. It has ID 153, and then we have I don't remember the zone name for the death route. Sounds like no, not that. Okay. It doesn't have catch in it because it's not entirely catch. Oh, it's HQ, not HG. And then we have this elevator, which, as you probably know, when you get off this elevator and move far enough here and go back, you can use this elevator again. So for that reason, the first position is here, the last position is here, and when it's catch, it comes from here and brings you here. Okay. It was a weird side thingy that I felt like explaining. Now you can use interpolate, third position, linear. I'm just gonna use order 1.5, and we wanna give it how many positions? 28. Seems good. So we have added the elevator catch into easy, which is ID 413, and so the elevator here we'll have 413 as this argument, which is the catcher's ID. This argument is 16, and this argument here is a bit complicated. It is 0 if you have elevator catch, but it is 1 if you have no elevator catch. For example, if you go into spaced out, the gem route, the blue gem, let me just search blue, very cool. Now this elevator takes you all the way to the gem route, and as you can see, it has no elevator catch. It just sort of takes you, and in that case, it has this argument set to -1, which is all f's, and this argument is a combination of the gem ID, which it requires 3D, is the blue gem. It's 60 something. 3D is the blue gem. So this part is the gem requirement, and this here, this 01 or 00, defines whether it uses sketch or doesn't use sketch. And we will be using the catch version only, and we will be requiring no gem, so we will leave this argument as 0. Now the next 3 arguments are the x, y, z coordinates where the camera should warp you. Now we have to, in this zone, we have to also now draw the elevator. There's a draw list tutorial, but I just draw it at the first position and I'll draw it at the last position of this zone. And we can have a look at how it's behaving right now. If I haven't missed anything, it should make the camera switch and it should warp me somewhere completely out of bounds and kill me, but the transition should work. Now you can see there's a terrible quantity of things running on my PC, so it's lagging a little bit. Okay, so you can see it forced me somewhere, and it hasn't really done anything. I'm just sort of somewhere out of bounds, not able to interact or anything. If I also draw this, it should hopefully just kill me, because in this zone this catch object wasn't drawn. So I think the game got extra confused. Now, the game is running slowly, but you could notice a lag when I crossed this part, and that was because the neighbor TAEZ, which is this one here, isn't meant to be loaded in this area. We will be having a simple fix for that at the end. Okay, so for some reason the game has managed to put me onto the elevator, but it doesn't always happen. And so what you want to do is, in argument 6, 7, 8, you have the XYZ coordinates of where it should send you. If you go into the existing elevator and go into argument 6, 7, and 8, we can see some positions. And we will be wanting to calculate these positions for our new added elevator as well. So the positions are absolute for the level, which means we will be having to take the position of the parent zone of the elevator catch and adding elevator catch's position to it, so that when it warps us to approximately this point. Now the zone position is in the zone second item, which is the collision item. The first 4 bytes are signed word, and they are X, this is signed word, Y, Z, and these are the dimensions, width, height, and depth. And they are big endian. If you know what it means, you know what it means. okay, actually, I'm not sure which one is begindy and which one is not, always confusing. But the way the number is interpreted is backwards, which means O2 the fourth FF, which is 185,500 blah blah blah. And same way we will be getting the Y coordinate, which is 3,400, and Z coordinate. That coordinate is sine, so we have to do this. FFFF FE 70, which means it's minus 400. X, Y, and we will be adding 4 times this catch's position, the last position, because that's where elevator catch starts. That's just how it is. So plus 4 times 150, plus 4 times 100, plus 4 times 700. Now this is like 2,400, this is 3,530, and this is 1,800 plus 222 is 1,878. So these are the coordinates for the sender, which we are gonna put in these arguments. This is the X, this is the Y, and this is the Z. So even though it worked before without having the coordinates correct, it doesn't always work if they aren't correct, so you want to have them correct. And we now have it correct. So if you want to be correct and make sure that it doesn't happen the camera is in 1D and we make the camera scroll to 1D and then the transition happens, we also have to add the property and the camera link and the neighbor into 1D. Now if it were at the beginning or end of the segment, you wouldn't have to do it, and right here you also don't exactly have to do it, but if the elevator was exactly positioned so that the camera is near this transition, it is correct to add the transition property into this camera as well. Replace. Where did they export? Cool. We'll be exporting from 6 into 1D, 1A8. It's there. We put it back in. Now you can see that this camera has 25 positions, so its last position is 24, and 24 in hex is 18, and 18 was coincidentally also the value which this property uses. So we don't have to change this 18, but if it had 26 positions, we would change it to 25, which is hex 19. So only thing that will be changing here is this one, which might not even be necessary, but I'm not sure. We'll also be adding DAEZ as a neighbor. So flag, and it was I think 7B, C7, 57, 7A. It was not 7A, it was 7, 6E, 6E. DAEZ was added as a neighbor. We also want to draw this elevator. So I just patch list real quick, and we add a new path link. And the path link is at the end of this camera. So we want to go here, insert a new, it's called neighbor here. Zone index is 0, 1, 2, 3, 4, 5. DAEZ is the neighbor 5. Not there. I'll go here. So it's neighbor 5, and we are connecting to the 0th zone, 0th camera of DAEZ. Link type 2 means that it's at the end of this camera, and link type flag 1 means it's connecting to DAEZ's beginning. So this is correct, and we are drawing this. So if we move this elevator like here, it should work. Also, the game should lag a bit earlier. Yes, it lagged a bit. That's because it had to load a chunk which DAEZ. It had to load chunk 119, which it normally didn't, because the lists that tell it what to load in this area obviously didn't include loading something that's entirely elsewhere. So it didn't have it loaded in advance, and it had to lag to fetch the data of the zone. Now it works. Now if you want to have it look nice, you would also make this not clip, and you would make it not undraw while the camera is still looking at the elevator, but that's cosmetic. If you wanna fix this lag, at least somewhat, the easiest way is to load DAEZ in this area, and that we do by loading DAEZ in zone 1D. It's loaded from the first position to the last position. We also load it in in 1E. It's loaded from the 0th position to the last position. And the way loading happens is not instantaneous. So even though it is loaded in this zone, if we now patch NSD, we have to patch NSD because we have just appended to the list DAEZ, and this list has a specific order which is based on the NSD file, and if you patch NSD, it corrects the order, and we save. And when we go into 1D now, we will notice that it still lags. It lagged, and that is because loading is not instantaneous. So in order to have it not lag in 1D, we have to also load one zone in advance. So we have to load in the zone before 1D, which is 1C. We load DAEZ, and we have to load in one zone after 1E. The reason we are loading in 1F is if right now we went through and went into 1F, it wouldn't lag, but there could be a case where someone backtracked, they went into near end of the segment and went back, and by the time DAEZ would be deloaded and 1F isn't telling it to load, so it would lag here. So we also have to load one zone after. One zone isn't very accurate. It's sort of rule of thumb. Sometimes it's enough, sometimes it's not. If it's not enough, you load a little bit more in advance. It all depends on how much is loaded, how much new stuff it's trying to be loaded. So now the only lag that happens is on the transition, and the transition lag could be fixed also just by adding stuff from that's used in TAEZ. You can see there are a bunch of loads here, and to make this lag not happen, we would have to also load in advance this scenery and also a music entry. That's also a thing. And we would also have to load all the neighbors. Now in this case, TBEZ is in the same chunk, so it wouldn't exactly be an issue. So as for demonstration, we will be loading all that stuff as well. I think it was 24 EW, which is the road geometry, TBEZ, and SNO, no, SN2 EM. Is it SN2? SN2 EM, SO2 EM. Yes, that's the music entry. So we wanna load SO2 EM. Now if we don't load 24 EW, you can see the payload is 13, but if you load it, it's more. And SO2EM doesn't make the payload bigger because it happens to be in the same chunk as these smashers, and these smashers are already loaded in 1AE or in 1D. So the only thing that should have to be added is the scenery, and we add it into 1D and 1E. We don't really have to add it into 1C and 1F because by the time you move from here to the elevator and the transition happens, it should have already loaded that one more chunk. It doesn't need the 24. Scenery in here only needs it after the transition happens. So right now it is loaded in advance. So it should not lag anymore. And one of the upsides of this emulator is these debug prints, which tell you which entries are requested by the game and which chunks are loaded. So that way, when a lag happens, it is easier to tell what caused the lag. So it didn't really lag here, I think. An easy way to notice whether it lags or not is to look at these counters. So my PC isn't liking what's happening to it. Okay, hopefully deloaded lots of stuff. And you could see that they didn't stop, so it didn't lag. And all these new loads are happening from TA. And TA is already trying to load stuff from this here in advance. So in conclusion, what we did is we placed a new elevator in the zone. To find out the elevator's arguments, we just looked for another elevator. We don't have to remember all these arguments. 647, this is the catch ID, this is a constant, this is 0, this is the X, Y, and Z target, and we also copy type and subtype. So (9)6 type subtype. This is constant. This is constant. This is the ID of the catch elevator, which we have added in the target zone. You can see it's LF catch 413. And these are the positions. This is X, this is Y, and this is Z. And the way we calculated it is we added the origin of the target zone, or actually of the target elevators zone, which we got from here. For example, 2D4 FF is 185,599, and we have added the elevators last position times 4 to each of these. So we have added to X, we have added 4 times 150, to Y we have added 4 times 110, 100 only, not 110, and to Z we have added 4 times 700. So these final numbers are the arguments of the elevator that sends to you. Then we added a new camera link. Since the transition should happen when the camera is near this end, we have added a new neighbor at the beginning at position 0, and the neighbor zone is zone 5. Neighbor 5 is TA easy. TA easy is the target zone. So we have added this neighbor. It wasn't there before. To add a neighbor, you increment this, which is the neighbor count. You write the hex representation of zone name here, and you probably use 1F here. And the way you find out the hex is either by putting it in this program, EID and the name, or you could go into TA easy and at the beginning scroll down, press Z, and you would see TA easy is 7BC7576E. So we have added the neighbor, and we have added a new path link. Zone index 5 means it's the 5th zone here. I said that already. Oops. Link type 1 means it's the link happens at the beginning of this zone, not the end. Flag 1 means it connects to the beginning of the AEZ, and camera index 0 means it's connecting to the 0th camera of the AEZ. And also we have copied in property 1A8 using prop replace thingy. Oops, I didn't mean to do that. So we have done just prop replace, and we gave it the first camera item from some zone that has the property, and we copied it into the camera that we wanted, 188. We have also changed a value in the property. This was 18 before, and we have changed it to 0 because the transition happens at the 0th position of this camera. Now we have done a similar thing in the zone before, because the elevator could be at the very point, or it could happen, the elevator could be somewhere where just by moving on the elevator you would move the camera from 1D to 1E, And for that reason, we have also added the neighbor, we have added the camera link to zone 5, link type 2, which means it's a link at the end, flag 1, position 24, and we didn't have to change this 18 because the 18 equals 24. And also we have added the elevator into draw lists, so it shows when we are around. And we have in TA Easy added the elevator catch into draw list so that it shows when we are here. And as extra, we have also loaded TA Easy in zone 1C, which is the zone before 1D, and in 1D, and in 1E, and in 1F, so that it doesn't lag when you come near it. So I think should be about it for making segment transitions. We use this mostly to stitch together segments from different levels and to make new level layouts or designs. So that should be about it.